Alright, welcome back to this video series on control structures. In the last video we looked at a while loop and a for loop. And so here's the code that we worked on last time. A simple while loop that will output 0, 1, 2, 3. So here's our initial control variable, here's our condition. If this condition proves to be true, it'll continually iterate or continually loop through until it's false. But the three things that we need for any looping structure is we need this control variable, initial control variable. We need the variable that's going to be tested within the expression or the condition, and we need something that's going to alter the control variable. All right, in this video, we're going to discuss the concept of defensive programming, and then also this concept of priming for input. And you'll see that there's going to be a term called Sentinel value that we'll use within our condition to test against. So let's jump back to this problem here that we coded out in the last video. You'll see that the code is similar to what we have here in the slide. This one here just outputs numbers 0, 1, 2, 3. It's not going to output 4 because it's not the relational operator is not inclusive with the equal sign. And so it'll start at 0 while count is less than 4. So while 0 is less than 4, it'll output hello, and then we'll increment our control variable. It'll do that 3 times, or 4 times, and then it'll output goodbye. So very similar to what this program does here. We're just using less descriptive variables, x and y. And this one here uses better variables to depict what's happening. And then here's the pseudocode for that. What I want to do here is talk about this idea of priming for input. So we already saw that we need these three things. We need the loop control variable. We need the variable that's going to be used to test against with our condition, and something that's going to alter the variable. And that's in a while loop that's within the body. So let's go ahead and alter this program. And what we're going to do is we're going to create a simple program that allows the end user to continually input their favorite numbers. And then they can enter a Sentinel value to exit out of the while loop. And a Sentinel value is a variable that we'll test against in our condition. And so, for instance, the Sentinel value here is something that we want to test against that would actually break us from the loop or get us out of the loop, or make the expression prove to be false. So what we'll do is we'll say, I'm going to say final, and I'll just say exit, or let's give it this a int exit equals, and we'll just put -1. Or let's put 999 because I'm going to use, well, let's do -1. That works. And then here I'll put exit and say, well, x is not equal to exit. And I want to change x to favnum. And again, the end user will be able to enter their favorite numbers up until 10. So they can enter 3, they can enter 4, but they can enter up to 10 numbers. So I'll change x to favnum. And we'll initialize x from the console. So when the user will be able to initialize the favnum variable. So we're getting rid of x, and then they'll be able to use, we'll assign favnum based from when the information returns back from the console. So here, let's go ahead and let's do a simple output message that will let the user know what this program does, and then we'll receive input. So we do a sysout, tab twice. This program will allow you to enter up to 10 numbers. I'm going to do another output statement here. Enter your number, enter a number, or enter -1 to exit program. And so once we actually use it for some ask for a value, we're going to receive that from the console. So we'll say favenum equals, and then here's where we're going to need the scanner object, right? And so we'll import that. I'll declare an object instance of it. So I'll say scanner. I'll say cn. You can name this anything. You can name this input if you want. Equals scanner, new scanner. System add in. And it's giving us this red squiggly here. It's because we need to bring in the import statement. I was hoping this gives me the, let's go ahead and right at the top here. I was hoping that was going to give me just the option to go ahead and click the button and import it. But we'll just say import java.util.scanner, and that should be fine. So here we'll say input dot, and it will, and what I'm going to do is do the integer class. I'll parse it, and then say input dot next line. So here we have favenum, and this is where we're going to initialize favenum. We can actually go ahead and get rid of this int y equals 3. And then here's our sentinel value. I'll put a comment here. And the sentinel value is a particular variable that we'll test against in our condition, and that's what we're doing here on line 17. So while favenum is not equal to exit, then we'll just output the number. But then watch this here. Instead of actually incrementing, I don't want to increment my favorite number. I am going to ask for the primer again, and this here will be considered the primer. What's on line 13, and we'll ask the same question again within the midst of our loop. So I'll paste that in. Let me just close this down here. Yep, so we can get more view of the screen. And so the end user will be able to enter a value up until a sentinel value is entered. But remember, the demands of this program is that they can enter a number up until 10 numbers are entered. So we need another condition for that. So here we're testing for the sentinel value, which is exit equals -1. Or we could say and fav or count is less than 10, right? So watch this here. I'm going to count how many times the user actually enters into the block of the while loop. So I'm going to declare int count equals 0. In this case here, I'm going to start off at 0, so I declare and initialize all in one statement. And so both of these conditions have to be true to go into the block. So if one of these conditions is not true, then it won't go into the block. It won't go into the block of the while loop, and it'll go to the next statement. At the end here, I'll just go ahead and say sysout exiting program. All right, so this meets the demands of the problem. And this problem will allow you to enter up to 10 numbers, enter a number, or enter -1 to exit the program. So let's go ahead and save this and run it and see what we get here. All right, so let's go ahead and enter. Let's just start off by entering our sentinel value, which is -1, and that should give us program ending. All right, good deal. So let's go ahead and start our program up again. Let's run it. Now let's enter some numbers. Let's put 2, 3, 4, 4, 3, 3, 3. Okay, so I've entered way more numbers than 10. I've entered way more numbers than I should be allowed to. So the question is, what is the issue here? What is the problem? And the problem is that, if you remember, we need three things for our looping structure. So when we're collecting our favorite num, that's good to go because we have the priming input, we have the fav num, where the user will input a number, we have a condition, and then we're altering that value here with our primer. But the other thing is that we have another expression here, right? We have the initial value, which is count equals 0. We have the condition, while count is less than 10, but we don't have anything that will alter our initial value of count. So remember, we wouldn't allow the end user to enter up to 10 numbers. And so to do that, we're going to actually need to alter the initial value and to keep track of that, the actual count. Because right now what we have is we can continually enter numbers past 10 because count is not even incrementing at this point. So to fix this here, you're going to say count plus plus, which is the same thing as count equals count plus 1, right? So now we save this, Control S, and run this program again. All right. So let's go ahead and enter numbers 2, 3. And once we get to 10 numbers, it should break us out of the loop and say program ending. There it is, right? Let's run it one more time. This time here, because the conditions of this problem is that we can enter up to 10. So if we want to enter 3 or 4, we can do that. So we'll press play. And let's go to enter, oops, not there. I want to enter in the console. So let's enter two numbers, 2, 3, and 4. And let's enter our Sentinel value. And that should break us out of the loop, right? Program ending. And so we're introducing two new concepts here. One is this idea of using a primer. And priming is just like, again, it's just like if you're using a lawnmower, you have to give it some gas, right, to get the lawnmower started. And then once the lawnmower is on, you can continually feed gas into the engine. And so that's what we're doing with this while loop, right? This is our primer on lines 14 and 15, and we ask the same two statements again within the loop to test this particular condition. The second thing is that we're using the variable to actually increment or keep track of or keep count of. And so here we initialize count equal to 0, and then here here's our expression, our condition, and then we're going to say that they can only enter this while loop a total of 10 times. And so count will increment by 1 every time we go into the block of the while loop. I was going to talk about defensive programming in this video, but it's getting a little too long, and I'll talk about defensive programming in the next video here. So stay tuned.